Right. Good morning, ladies and gentlemen. You are welcome for today's lesson that we did not have last week. Today we are supposed to be looking at compounds of sulfur, and the first compound of sulfur, briefly for interaction with, is a compound called hydrogen sulfide. So I want us to look at hydrogen sulfide. I'm going to be very brief on hydrogen sulfide because our syllabus states that because of the poisonous nature of hydrogen sulfide, we should try as much as possible to avoid ourselves and our students to come into contact with hydrogen sulfide. But there are just 1, 2, 3 things that they expect us to know, and those are the ones that I'm going to base on. Number 1, we may not go into the laboratory preparation. Laboratory preparation not allowed. So it's supposed to be a teacher demonstration experiment. So if at all we are supposed to look at hydrogen sulfide, how do we production of hydrogen sulfide, which is a gas? It is as a result of a reaction between iron 2 sulfide and dilute hydrochloric acid. So it means these two are our reagents. What are the conditions for the reaction? The conditions require that the acid must be dilute, and this reaction is going to take place at room temperature. What follows next? If we wanted a pure sample of the gas, our drying agent is expected to be concentrated sulfuric acid. And in our usual style, why do we use concentrated sulfuric acid? Because the acid is an acid, as you have heard. Hydrogen sulfide is also an acidic gas. Therefore, no chemical reaction takes place between hydrogen sulfide gas and hydrochloric sulfuric acid. So we use sulfuric acid, reason being the gas does not react with the drying agent because it is an acidic gas. If we wanted to prepare, then method of collection, if wanted, the method of collection is supposed to be downward delivery. If not dry, it can be collected over water. Now that is what is expected of us. But because of the poisonous nature of the gas, drying is not wanted, collection is not wanted. Therefore, whether downward delivery or over water, practically we don't do the following. It therefore means we are left with knowing substances that can give us hydrogen chloride and the conditions for the reaction. I therefore want to summarize this in the form of a simple word equation followed by a chemical equation. So we are saying iron 2 sulfide plus dilute hydrochloric acid The first thing we are getting is the gas we are looking for, which is hydrogen sulfide. What follows next? When you check in the system, we're going to end up with iron 2 chloride. From the above, we can come up with a chemical equation. The formula for iron 2 sulfide is that one, FeS, it is a solid. Hydrochloric acid is HCl, and it is aqueous. So what is this that we are calling? I'm just adjusting. This is iron 2 chloride. So what are we obtaining? Hydrogen sulfide is H2S, and it is a gas. What will be formed? We said iron 2 chloride is going to be FeCl2, and this is aqueous. So from here, you can endeavor to find out whether our equation is balanced or not. We shall check. There is one atom of sulfur, iron here. Iron, there is only one, you can see. Sulfur is only one. Here hydrogen is only one. Chlorine is only one. This way, hydrogens, you have seen are 2. Sulfur is 1. You have seen iron is 1. And chlorine are 2. So what is not balancing? It is hydrogen and chlorine. This side we have 2 hydrogens and 2 chlorines. This side we have 1 hydrogen and 1 chlorine. What does it mean to make the number equal on either side? We shall increase this side. So which number do I multiply by 1 and I get a 2? It's supposed to be a 2. Therefore, we shall put a 2 there, and we end up with our balanced equation for the reaction. So I want my students to know that iron 2 sulfide and hydrochloric acid gives hydrogen sulfide. Iron 2 sulfide, dear ladies and gentlemen, can also react with sulfuric acid, and it will give the same hydrogen sulfide. But this time, what do we get? We shall get iron 2 what? Sulfate, aqueous. This is a gas. This is aqueous, and this is a solid. So what are we capturing in today's lesson? Any acid is capable of reacting with iron 2 sulfide and to produce hydrogen sulfide gas. It is supposed to be in very small quantities. Actually, the experiment is done in a test tube. Though in the notes we have a setup for general methods of preparation of gases, but practically is a test tube reaction to produce a very small amount of hydrogen sulfide, because the gas is extremely what? Poisonous. Even that test tube reaction will produce hydrogen sulfide that will disorganize the whole class and other classes, even in very small quantities. Therefore, we cannot dare try this experiment unless you have a fume cupboard. How many schools have fume cupboards? Just very few, among which Chibuli is one. So, because of that very poisonous nature of hydrogen sulfide, we don't prepare and collect, we demonstrate. So when it comes to gas preparation, that's why in my table I did put the hydrogen sulfide, but I put there other gases. So this is the reaction that leads to formation of hydrogen sulfide. I've already mentioned that any acid can work. So we can come up with an ionic equation. Iron 2 sulfide is a solid. What is an acid? A substance which when dissolved in water produces hydrogen ions. So being an acid, I am interested in hydrogen ions. So what will I obtain? We shall obtain hydrogen sulfide as a gas plus iron 2 ions, aqueous. So these iron 2 ions can be in the form of a sulfate, can be in the form of a chloride, and not to get a shock, even nitric acid will give, because after all what we're interested in is hydrogen ions. So even when you put ethanoic acid and iron 2 sulfate, you still get hydrogen sulfide. That's why I'm picking out one thing, hydrogen ions. So what is the content? Any sulfide, by the way, so even if I brought zinc sulfide, it will work. Even if I brought magnesium sulfide, it will work. So the most important thing is a sulfide of any nature plus an acid of any nature, as long as not lead. What do you get? Hydrogen sulfide gas. This gas is acidic. But before even test with litmus, we have already detected it. So it's an acidic gas. So what do we do if it's an acidic gas? It turns, therefore, blue litmus to red. That is one thing we use to detect the presence of hydrogen sulfide. But there are many gases that turn blue litmus paper red. Many gases that turn blue litmus paper red. Identify those gases. Carbon dioxide can do it. Chlorine can do it. Hydrogen chloride can do it. Sulfur dioxide can do it. Sulphur trioxide can do it. Nitrogen dioxide can do it. So there are many gases that are capable of turning blue litmus paper to what? To red. However, nitrogen dioxide is a colored gas. It is brown. So I remove that one. Chlorine is colored. It is pale what? Yellowish what? Green. This gas is colorless. This gas is colorless. This gas is colorless. Pure gas, hydrogen chloride dry, is colorless. And all of them turn blue litmus paper red. So how do you tell which is which? There is a unique test for each one. For this one, what do we use? Acidified potassium dichromate. We are going to see it. For this one, what do we use? Lime water. And this gas does not smell. So this one has no smell. This gas, the cheapest common test is physical. By use of its characteristic what? Smell. So we don't have a chemical test. Before even bring litmus, you have already detected the smell. So what is the smell of hydrogen sulfide? It has a smell of rotten eggs. Or rather, a smell of rotten cabbages. This explains as to why Muvitogo in the swamps, you pass and get repulsive smell, because there is a lot of hydrogen sulfide being deposited in Muvitogo from proteinous what? Substances. The beans go bad very quickly because they produce a lot of that, have a lot of sulfur in it. When you eat eggs, boiled eggs, 3, 4, 5, the repercussions are yours. You know nobody wants to be near you because of that gas, which has a very repulsive smell. Very pronounced, very strong. And this gas is extremely what? It is extremely poisonous. Basing on that, we limit the chemistry of hydrogen sulfide. Basing on its unique behaviors, we are going to limit the chemistry of hydrogen sulfide. So don't ask me, hey, but we have not drawn a diagram. We said we end on the test tube reaction, particularly. All right, so characteristics of hydrogen sulfide gas. We shall not go into very many. Number one, properties. What did we say? Blue is going to turn to red. We said smell of rotten eggs, or rotten egg smell, or rotten cabbage smell. Rotten cabbages also smell like rotten eggs because of the sulfur that is found so much into them. Number three, the gas is sparingly soluble in water. And the A levels are the ones who get so much interested in this property. So for us as O-level students, we are going to go into the chemistry of sorbate of hydrogen sulfide. And that will explain why it is acidic, because hydrogen sulfide, at our level, I would say a gas. When you add water to it, aqueous, it's a weak acidic gas, will give you hydrogen ions, aqueous, plus a sulfide ion, aqueous. But the acid is extremely weak. This time, even ethanoic acid is slightly much more better than this one. So, we shall leave it at that. Probably where you can discuss a few chemical reactions is a reaction between hydrogen sulfide and chlorine. This reaction, we saw it under the chemistry of chlorine. I'm picking out important issues. So, what do you remember about chlorine? We said chlorine is a very powerful reducing agent. It removes hydrogen from any hydrogen-containing substance. And what shall we form? White fumes of hydrogen chloride. And what will happen? Sulfur is going to be deposited. Since we have two hydrogens, this is supposed to be a 2. And therefore our equation becomes balanced. So this is hydrogen chloride gas. This is sulfur as a solid. Is one of the principal reactions that I expect my candidates not to miss out. And I told you the other week that for the chemistry of hydrogen sulfide, I'm just going to mention 1-2 things and we continue. So this is one of the reactions that we can talk about because we met it under the chemistry of chlorine and so on. Right? So this is what is expected. However, it is also possible that this gas can easily get oxidized to give you water vapor, sulfur dioxide can give sulfuric acid. So there are quite a good number of chemical reactions, but as I said, my emphasis is going to be on what is examinable content for us. So I'll ask you to get back to your work that we have uploaded and just appreciate those other chemical reactions, but I want you to pick out that reaction. So there is a reaction with sulfuric acid, fine. There is a reaction with nitric acid, it's okay, but this is what we met under chlorine is what I've produced back for us to review. I may not ask for any uses of hydrogen sulfide. So capture 1, what can give hydrogen sulfide? Number 2, how do you test for it? Number 3, know that it's a very poisonous gas. And one good chemical reaction is that chemical reaction, and we shall proceed to the next. So that is how brief I promised I would be, and I am, on hydrogen sulfide. Don't take a lot of time studying the diagram for preparation and for collection. It is a test tube reaction. Are we there? So that is that, and so on. So I want us a little bit to take off a little bit of time and discuss the next concept, which is very good. So the next concept which shall take off a bit of time and look at it is sulfur dioxide gas. I expect my students to name the reagents, state the conditions, physical properties, chemical properties, uses of sulfur dioxide. This one, plenty. is wanted. And we shall begin in our usual style of doing things. Number 1, let us identify the reagents or the chemicals from which we prepare sulfur dioxide.
Concentrated sulfuric acid.
You have gone a little bit ahead, but you are right. We shall have reagents first. Somebody has mentioned sulfuric acid. I accept. If not sulfuric acid, it can be hydrochloric acid. And we shall see of the two which one is better. We need a compound called sodium sulfite. You can also use potassium sulfite. And I want to mention, these two are not the only ladies present on planet Earth. There are other ladies with other names. But what makes them to be ladies is the word what? Sulfide. So it can even be magnesium sulfide. It can be zinc sulfide. So to be broad, we shall talk about nothing other than a metal sulfite. And we shall talk about an what? An acid. Generally, to be broad, and you cover as many aspects as possible. Those are the reagents. And this is the content. The remaining work becomes yours because we have covered all of this in senior 1. So what do we follow next from reagents? We go to conditions for the reaction. The conditions for the reactions entail that you'll need, and I'll make an adjustment on the notes because something failed me. I tried to do some editing somewhere, somehow, but I was a little bit caught up and the work was posted, which has a small error that you are going to correct. We shall need an acid to be a dilute acid. And therefore, this reaction requires that you do heat. So heating is required. I have always rejected the presence of heat. Presence of heat. Right now I'm in the studio and there is a technical team, there is a technical person handling the apparatus here. He is not teaching, but he is present. So when you say presence of heat has something else, it indicates that heat can be present, kept somewhere there. But when you say heating is required, or heat, it becomes very clear. We don't want ambiguity here. So, from there, can we head for drying? What do we use for drying? We have chosen the concentrated sulfuric acid. And in our usual style, the thing is, why do we choose concentrated sulfuric acid? What follows next in our usual style of essay writing? Method of collection. How do we collect this gas? By downward delivery or upward displacement of air. It's called downward delivery. If you don't want to call it downward delivery, we call it upward. You displace air upwards as the gas goes what? Down. So upward displacement of air. We covered all of this work from here in senior 1. Types of gases, types of drying agents. How do you choose a drying agent? How do you choose an opponent? All these things will come in the future. How do you choose your future wannabe? I mean, you have to look at certain things and so on. You prescribe, must be this because if it is this, it will be the other. Why do you want a tall one? American height. Oh, because ABCD, I am dwarfic, therefore I want to use biology, crossbreeding, that kind of thing. There are reasons. So you don't just say, I want American. Why? Just. It cannot be just. reasons. So again, why do you choose this method? I'll ask you, but why should you heat? And each time you answer a concept here, you are in line with the current presentation that every activity must have a reason. That's why one time when I was still young youth at your level, there was Fun Factory. They said to me, don't love me for fun. It's not for fun, there must be a reason. So we're not going to hit it for fun. We're not going to use sulfuric acid for fun. There must be a reason which is real, specific, because it's a marking point. Now from here, I do expect, if I was in face-to-face interaction with you, I could have instructed every student to write down the notes, draw the diagram, label it, and write the equation. So my only responsibility is not to write the equation, because the rest of the notes, like we have been singing, we know how we have been doing. Practice makes perfect. Tuchikole nera, again and again and again and again. So this is the again and again of you writing the essay, and you become perfect. Practice makes perfect. This is it. Now, person, but we have a certain content on the website is saying, and that's why one of the students quickly said the concentrated sulfuric acid, and I knew the next thing was, she was going to say, let us add what? Copper. Thank you so much. You'll get back when you are downloading the notes edit. It is okay. This reaction can give us sulfur what? Dioxide. But the syllabus says, students of S4 cannot handle concentrated sulfuric acid during preparation. So for that matter, therefore, we don't examine students on preparation of sulfur dioxide from concentrated sulfuric acid and copper. That's why the notes are speaking something different. The diagram is the diagram of copper. So get back that diagram of yours in your notes. Delete copper. Put there. What shall we put there? Sodium sulfide. Where there is concentrated sulfuric acid, put dilute. Why? It's because when you give this as a method of preparation of sulfur dioxide, you'll earn nothing. And in the questions, it is not possible. They will say, how do you prepare sulfur dioxide from? But we studied this reaction as a property of sulfuric what? Acid. It will come as a property of sulfuric acid, but not as a method of preparation of sulfur dioxide in the lab. And I hope, my dear students, you have picked that information. I beg to repeat that we don't prepare sulfur dioxide from copper and a concentrated sulfuric acid, but we look at this reaction as a property of sulfuric acid. We prepare sulfur dioxide in the laboratory from sodium sulfite, potassium sulfite, and any of the dilute acids. If you are given an opportunity to choose, which of these two acids could you have chosen? It's not a question. And I'll begin the one who is in the studio, because for you, your answers will come later. Which of the two, sulfuric and hydrochlorous, could you have chosen? Sulfuric. Why? The person in the studio has chosen sulfuric acid as the first date. Why?
Because it's also acidic.
She said because also acidic. That may not be a very good reason. It's because this acid doesn't vaporize. This acid is not volatile. This acid is volatile. As giving out sulfur dioxide, the sulfur dioxide will be contaminated with some hydrogen chloride. It doesn't give very pure. Because the diagrams, we don't say pure. We only go for dry, and you must go for the best. So the best choice acid is that one, because sulfuric acid is not volatile. All are clothes. Then why do you choose to put on another dress other than putting on uniform and you go for senior 4 farewell party and dance? I saw when the senior 4 last year were having a duel, people were dressed to kill. None of them was in uniform. So why did they pick on uniform? It was not an appropriate way at that moment. So do you think it's happened? How do you go to the beach when you are putting on a gomesi? It is not appropriate. So gomesi plus patra, you go for your patra. It is appropriate, but all of them are aware. So sulfuric acid is much better than hydrochloric acid because sulfuric acid is not volatile. Hydrochloric acid is volatile. You end up getting sulfur dioxide contaminated with traces of hydrogen chloride gas from hydrochloric acid. So this is it. I'm therefore calling upon my students to figure out the equation. Therefore, like I've said, how to choose the best acid. So what's the best acid? Sulfuric acid. So what is the formula for sodium sulfite? Sodium sulfite is written like that. SO3. And sodium sulfite is a solid. Let me add sulfuric acid. Dilute, it is aqueous. What does it give me? We shall first of all form sodium sulfate, which is Na2SO4. If I use hydrochloric acid, it will be sodium what? Chloride. Plus, and it is aqueous. What else do we get? The gas we are looking for, sulfur dioxide as a gas. And what else is formed? Is water as a liquid. Right? So the equation is automatically balancing itself. If I use the hydrochloric acid above, I should have had 2 moles of hydrochloric acid and therefore 2 moles of sodium chloride. So that is the equation. I think you can figure out the diagram. So what type of gas is this? Is it a GC, GDC, GPDC? I've used those terms over and over. I've been talking about a GC, GDC, and a GPDC. What type of gas is this? Is it a GC? No. What is GC? Generate, collect. You see the idea. So it's not GC. Is it a GDC? What is the GDC? Generate, dry, and collect. Most likely, is it a GPDC? No. What's GPDC? Generate, purify, dry, and collect. So it's not. So if you have to draw, how many setups do we have? 3 setups. Generation flask, under heat, drying flask, collection gas jar or flask. And I know you can draw that one even without the presence of a teacher. Even when you are dreaming, you can draw and label. So what is the essay? What shall we put in the flask? Sodium sulfite is put in the flask because it is a solid. Full stop. Statement number 2. Dilute sulfuric acid is poured down into the flask through the thistle funnel because it is a liquid. The mixture is heated to start off the reaction and drive sulfur dioxide out of the solution because the gas is very soluble in water. So the purpose of heating start the reaction at the same time limit solubility of sulfur dioxide in water. Otherwise, without heating, the gas is formed but doesn't come out. The way we drive you from dormitory after lunch to go back to class. If not, you don't come out. So you have to come and drive. Hey, the bell has gone. So you quickly dash out of the dormitory. Otherwise, if we left you, you would sit there and come out maybe at 4 when I've already tired of waiting at the class in the classroom and I've gone. So the gas does not readily come out because this gas is very soluble in water. So the purpose of heating is to limit its what? Solubility, so that it gets what? Out. It's like visiting a toilet which is smelly. If I don't want to stay in the toilet for a long time, I make sure put the decomposing material. The minute you enter there like this, oh, the smell drives you out immediately. But if you find perfume, spray, roll-ons, you find newspapers, you find chocolates, air conditioning. When you get out of the room, you will continue to stay there longer and longer, 5 hours, 6 hours, you're not coming. What is happening? So why are we heating? The mixture is heated to start the reaction and drive sulfur dioxide out of solution. The gas is passed through concentrated sulfuric acid to dry it, because the gas does not react with the acid since it is also acidic. The gas is collected by downward delivery because it is heavier or rather denser than air. What follows next? Equation. What follows next? Diagram. Remember, we have how many questions about gases? 3 questions with the aid of a diagram. Diagram is not required. Draw a labeled diagram. I'll not go back to look at those 3 questions because we spent a lot of time looking at them at one moment. I'm now just saying applicable. So ponder over the 3 questions about gas preparations. So with the whiteboard erased, you can figure out the diagram. Of course, we talked about a flask. Maybe this is the flask. We talked about the source of heat. This is the source of heat. We're talking about pouring, putting the solid. I have put the solid. We say that, make sure that you pour the acid down into the flask through a thistle funnel. That is the thistle funnel. Then we said, you get the gas out. I must get this gas out. And it must go somewhere. To make sure that there is no problem, I am closing off those parts. I either put a stand or clamp hold. So since this one can sit, maybe I can put this on a stand. Pass the gas through concentrated sulfuric acid. This is my concentrated sulfuric acid. And we say the pass through, which means the gas must bubble through. Now the gas must come out, and we say, you collect me by downward delivery. And therefore, to avoid any error, we shall close off that point completely. So what is this method called downward delivery? Downward delivery is when the gas is coming in and the test tube, the delivery tube is facing down. We agreed that when you are drawing a gas jar, the gas cover should not touch the delivery tube. The gas is being delivered downwards as air is being displaced upwards. And therefore, I expect all my students to be in position to label this diagram with a lot of ease. So what is that? That's why I said delete concentrated and put what? Dilute. What is this? Don't put copper. I've given you conditions as to why. Therefore, this is my sodium sulfide. So what is this? The source of heat. What is this one? We agree that is concentrated, and we said don't write abbreviations, write full sentence and words. So concentrated sulfuric acid. Never be in a hurry to write Coke H2SO4 or Jakutomera. Take your time. So what is this? Your gas sulfur dioxide. The spelling must be correct. I want to remind you that when you are labeling a diagram, we insist on correct what? Spelling. Label arrows must be there. The diagram, make sure that your delivery tubes don't have sharp bends. Make sure your diagram does not leak, doesn't have a fault, such that even if you fail labeling, you get 1 mark for the diagram. WA 1, WA 0 if it has a fault. So, this is a setup. You can see the GDC very clearly. Generation, drying, and collection. And what did we agree? If they say diagram only, put as much information in the diagram as possible. Heat to drive, start and drive. Concentrate to dry, blah blah. Sulfur dioxide by this method, and so on. Label the diagram maximum, leave no room for somebody to ask the diagram that cannot answer, because you will not be available. So you draw a talking or a communicating diagram. Without a diagram not required. What did we agree? If we say the diagram is not required, we agree that you construct a diagram in sentences. Sample answer: sodium sulfite is put in the flask because it is a solid. The flask is fitted with a stopper having a thistle funnel and a delivery tube. Dilute hydrochloric or dilute sulfuric acid is poured down into the flask through the thistle funnel because it is a liquid. The mixture is heated to start the reaction and drive out the sulfur dioxide. Using a delivery tube, the gas is passed through concentrated sulfuric acid in a wash bottle to dry it, because it does not react since the gas is also acidic. Using another delivery tube, the gas is collected in the gas jar by downward delivery because it is denser. You can see that a muzibe, a blind person, can draw a diagram in his or her head, because I said, please don't draw, but communicate the diagram in words. Unless you have a problem, you cannot say that you can now fail to answer a question on gas preparation. And from the time I said, most likely, this is the last gas we are preparing in the chemistry of senior 4, because we are going to go into other things that are pending and quite very crucial. So I sign out on the preparation of sulfur dioxide. I want to inform those who have come in a little bit late that we shall not prepare sulfur dioxide from a reaction between copper and a concentrated sulfuric acid. The syllabus does not allow, though it is true a reaction will take place. All right? Visiting the neighbor is around is okay. What about if the parents say never visit the neighbor? So when you visit and they find you, then they will deal with you. So visit sulfur dioxide from copper and sulfuric acid. The examinations will deal with you by denying you the marks. Please edit your diagram. Make sure that we have what we want. I want to go into now the physical properties. Physical properties of sulfur dioxide. Physical properties. Sulfur dioxide is an acidic gas. Nobody asks you these physical properties. You only need them in a lab during a practical. No question will ask you for the physical properties. Being acidic, what happens? Blue litmus is going to turn into red. It has an irritating smell. It has an irritating smell. Any other? We now go in. These are the two major physical properties. Blue litmus, paper red, irritating. So you need this in an inorganic practical qualitative analysis. Now we shall go for how do you tell that the gas is sulfur dioxide? Chemical test for sulfur dioxide. Equation we wrote. We test for sulfur dioxide using acidified potassium dichromate solution. My dear students of O level, we don't want you to strain yourself with technical details of what happens. You just need the observations. Why you have seen that you don't know. So if you will struggle to write equations to explain, you can do it, but nobody will appreciate you with a mark. Your work will just be C. So if work is going to be C, you're not going to be appreciated. You wait. In the A level, explain more and you get the marks. So I've seen people struggling with the equations, giving students the equation, explaining the concept. That is not your work. That is not your responsibility. It means that the teacher does not exactly know where to end in some of this content. And it happens. So you as a student, you can use a certain compound called acidified potassium dichromate. Its formula is not your responsibility. But at least you can appreciate the color changes that take what? Place. And you stop there. I'm not supposed to be knowing why you have applied a certain type of makeup. I'm not supposed to know. Mine is to see, oh, she has applied. Okay, gosh, she's nice, period. But why you chose that is not me. How you did it, I'm not supposed to know. Alright, so acidified potassium dichromate. Sometimes we even cut out the word acidified because the gas itself is what? Acidic. It will automatically make the solution what? Acidified. So if you are acidic and you sit in water, automatically the water becomes what? Acidified. So we don't insist on acidified, but we insist on potassium dichromate. It must be a solution, not a solid. Because for solids, reactions will not take place. The color of acidified potassium dichromate is orange. And at the moment sulfur dioxide passes through the solution, the orange solution is going to turn into green. And in the chemistry, it shows that a reaction has taken place. And at our level, the only gas that can give us this property at our level is sulfur dioxide. There are others, but in the future. But at our level, it's the only gas that can do that. That's why it's a unique test for sulfur dioxide. Isn't it? Hey. There are certain guys, and you know them, very many. And you must be careful. A certain guy presents himself as the only one. But there could be other only ones behind, but you never allow, you know. This is the case. It's only sulfur dioxide that can do this. Others, for us, we don't know. And therefore, I limit this. What does it mean? The technical details of this reaction, you leave it. It will come in at the right time. Right? As for now, children bought from the supermarket. Period. Not ask me how much, how. No. Until P7 biology, S4 biology, we tell you now the technical details of buying the children in the market. We shall stop at this level. But this one is a reduction reaction. Because this compound, green, is called chromium, which is not your work. A level. I'm waiting for you. We shall talk about this. I don't want the equation. But if you so much want the equation, we can generate it. But it's going to eat on our time. I don't want. Because it's very easy to come up with the equation. The senior 6s and the senior 5s do it practically in the lab, and we write equations. Alright, so students who are planning to say, what's the equation? No, please, I'm not going to answer that question. As an individual, send a message, personal, how to handle. So it's test unique. I'm now through with my table. For preparation of what? Gases. What did it have? Reagent, conditions, purification where necessary, drying, method of collection, test for the gas, and where possible, equation. The essay remains yours because you have done it over and over. Thank you very much. We now go for what we call chemical reactions, chemical properties of sulfur dioxide. There are so many chemical properties, but the ones that are obvious that my students should be having. You may fail to know all teachers in the school, but you cannot fail to know the head teacher's name, the deputy, the those, those kind of people. The subject teacher, others mutulabao just the other one who teaches what? But the head teacher doesn't teach, but you know the head teacher very well. The dining master, that one you know because food is food. So there are certain things I expect you to know in the chemical properties first. Common ones. And we have already met some of them in the chemical senior too. Number 1. Reaction of sulfur dioxide with water. So water plus sulfur dioxide. What do you expect? In senior 2, we looked at types of oxides. We had metal oxides called basic. We had non-metal oxide called acidic. We had those that were what? Neutral. And among the metal we had basic and amphoteric. Wonderful. What were those acidic oxides? Carbon dioxide was one of them. Sulfur dioxide was one of them. Sulphur trioxide was one of them. Nitrogen dioxide was one of them. And what name do we call them? Acid anhydrides. What is an acid anhydride? An oxide of a non-metal, when dissolved in the water, should produce an acid. So what will be the name of the acid? This acid is called sulfurous acid. It comes back. This one you must know is a head. You must know. If it's sulfur trioxide, you have sulfuric. And therefore, what's the equation? Water is H2O. It's a liquid. Sulfur dioxide is SO2. It is a gas. What is the formula for sulfurous acid? It is H2, capital S, capital O, A3, aqueous. In Maggio style, letters not tempted to touch, not modified at all. Calligraphy, not acceptable. Is it working out? Let's check. Does it work out? 2 hydrogens, 2 hydrogens. 1 sulfur, 1 sulfur. 1 plus 2, 3 oxygen, 3 oxygens. That one, Captain. At least fail others, but not that one. Eh? This is number 1. I pick out my 3 reactions that I must die with. Others, you can also look at them. Another one, okay, being acidic. It cannot survive an alkali. Eh? That's why it is not possible that an acidic substance in the studio, an acidic substance can miss an alkaline substance. It is not very possible, unless otherwise. So we expect a reaction automatically. So what is this gas? Sulfur dioxide. What is this alkali? Maybe sodium what? Hydroxide. Aqueous. One being an acid, one being a base. What do we expect? Neutralization. A reaction takes place. What will be the product? The first product I'm going to think of is when this one is in excess. When sulfur dioxide is in excess, we shall end up with a sulfite. We go back to, That's why they say you came from soil, you go back to soil, isn't it? So you came from sodium sulfite, you can go back. So what is the product? Sodium what? Sulfite, aqueous. What else will be formed? Water as a liquid. Problems of balancing. Problems of balancing. What do you see quite unique? 1, and this is 2. You don't hesitate. Quickly you transform and put a 2 there. Because of this one, now you check again. 1s, 1s. Oxygens are 4 in total. 2, 1 times 2, 2 plus 2, 4. 3 plus 1, 4. God is on our side. No longer Allah Masha, it has worked out. When you check hydrogens, there are 2. It is. But this is when in excess. You give me too much food without sauce. Or a lot of sauce with limited food. It is possible. The same reaction will take place if this one is in excess, but the product is different. So SO2 gas plus too much of the sodium hydroxide. This is too much. So what is the product? The product cannot be sodium sulfite. What do you think is the product? It is sodium. No, it can't be a sulfate. There is hydrogen sulfide. Aqueous. If this is too much, you'll get that. And I think it works out automatically. 1 sodium, 1 sodium, 1 sulfur, 1 sulfur, 1 hydrogen, 1 hydrogen, 3 oxygens, 3 oxygens. If this is too much. So sometimes the question is open, sometimes the question is limited. Give me little food and a lot of sauce. Sometimes we command, hey, for me I need a lot of food. Even if there is little sauce. And I say, hey, for me, you rather give me 1 kilogram of meat and 1 piece of cassava. And I'll say, give me equal. So the question can say, I want excess sodium hydroxide. The question can say, I want excess sulfur dioxide. The question can just remain open. You choose. But the marks will help you know. Are we there? I can't miss out this reaction. I begin with obvious things. Another obvious thing, before we continue, which you have been asked right from senior 1. The reaction with burning what? Magnesium. So what were you told about burning magnesium? Burning magnesium continues to burn in sulfur dioxide gas. What shall we form? To form magnesium oxide plus sulfur, a solid. Observation. Continues to burn with a white flame, white solid and yellow solid. A mixture of white and yellow solid. Gray continues to burn in a colorless gas, deposits a mixture of white and a yellow solid. Explain. What is your explanation? Oh, the flame is too hot. It gives out a lot of heat. And sometimes you put in feelings and a lot of heat. Therefore, sulfur dioxide does what? Decomposes to give sulfur and oxygen. So that flame will separate sulfur from oxygen. Even if it is so strong. So sulfur is separated from oxygen. Now magnesium takes advantage of that and takes up. And if things happen, KB, hey, I'm telling you, that girl, oh, she's very bad. That guy, you want to manage ABCD, terrible, ABCD, that's this. Then he piles with a lot of information. Even if I love him so much or her so much, we come here. And immediately end, the one who brought the information takes over. Why didn't you know? That's why we say don't listen to what? To rumors. So magnesium comes in the room of a flame. And therefore, sulfur dioxide not to hold. Sulfur dioxide separates into sulfur and oxygen. Magnesium said, cherondera taba mubbi. But it caused the... I leave it at that. So what are other reactions? At least I'm capturing my 3 first. And this is right around there. Others can come in. Others can come in. If you want the one for formation of the green solution, if you want, you can write the redox reaction. So, any other 4th reaction that one person can contribute? I've given 3. Any other possible reaction for sulfur dioxide? Reaction with hydrogen, somebody say reaction with hydrogen sulfide. Now these are possible reactions that are a little bit rare a bit. So what do you expect here? Expect formation of water and deposition of sulfur. And how many moles of this? Hydrogens are 2, oxygen is 1. I'm putting a 2 here. So hydrogens change to 4. I have to put a 2 here. How many sulfurs are these? 3. Right? So, quite a good number. But I've kept the 3. Quite good. So, plus a few others that you can add on. Like this one. The one for the dichromate. Are we there? There is strategic planning, there is hard reading and strategic reading. All right. Do you think this gas has gotten any uses? It's the question of debate amongst the chemists online. Are there some uses? There must be. Whether 10, whether 30, pick out your few. Like 3. Pick out your few. Like 3. And we see. All right. So there are other few chemical properties that are in your notes. I picked out 3 important ones that we rotate on. But there are others. Uses. There are quite many. Can you figure out like 1, 2, 3 of them? Any use of sulfur dioxide?
Preparation of sulfuric acid.
Now the first one is preparation of sulfuric acid. Think of so many things, but at least this one as number 1, and you are going to need it. How? We shall see. But you have already seen sulfur dioxide, sulfurous acid. What's the next? Sulfuric acid. Sulfurous acid, if you're a human being, sulfurous acid could be a person who is poorly dressed in public. And when people come in, you quickly what? Dress yourself properly. So the dressed acid, a properly dressed acid is sulfuric acid. The poorly dressed acid is what? Sulfurous acid, which means it's a very unstable what? Acid, and quickly turns to sulfuric acid. We shall see. Now that is one good use of sulfur dioxide. Another, this gas is used as a fumigant. What is a fumigant? For fumigating. for spraying. Being an acidic gas, it will kill crawling organisms, insects, mites, and so on. You must remember that this gas is a preservative in tinned foods. Why? Being acidic, it makes the medium weakly acidic with a small amount that it cannot allow growth of microorganisms that will result into decomposition of food. That is sulfur dioxide. Sulfur dioxide is a bleaching agent. It bleaches wood pulp. It bleaches sugar from brown to white. So it's a bleaching agent. So what do you expect? That also blue litmus paper should turn red and after some times to white. What does it mean? Sulfur dioxide is a bleaching agent. From blue to red, then from red to white. It has bleached. So one, sulfuric acid, fumigant, acidic kills crawling organisms. That's why used in the fumigation. Number 3 is a preservative in tinned foods. We're also noting it's a bleaching agent used in the textile, paper industry, and the sugar industry. Those in the studio, any other use of sulfur dioxide? Studio attendant. Any other use? Tell your friends. I want to hear you. There are only 4. We are done. You are still checking. That's why we said do prior reading so that we can move relatively faster. Check if there are any questions so far.
My chat is down.
Okay. Sulfuric acid, the fumigant, preservative, bleaching agent. Now what I tell you, pick out 1, 2 uses. These are so far 4 uses of the gas. So where are you moving to next? Most likely, briefly, you are shifting to sulfur trioxide. So if you have sulfur trioxide, a lot of information is not wanted. It might not be very possible for us to prepare sulfur trioxide in the lab. But we can look at reaction that can generate sulfur trioxide in the lab. Now, sulfur trioxide has a formula SO3. And this SO3, where does it come from? It's going to come from SO2. What does it mean? You have to add one what? Oxygen. So we are going to add by adding an oxygen atom. This reaction does not readily take place. I'm therefore saying that sulfur dioxide prepared, should you add one atom of oxygen An atom means oxygen molecule divided by 2. Should you add an atom of oxygen, a gas, you'll get sulfur trioxide, a gas. This is a stubborn reaction. As you are forming sulfur trioxide, it goes back to sulfur dioxide. Therefore, we use reversible arrows. It's a stubborn reaction. Without a catalyst, it's difficult, and the catalyst is V2O5. What's the V2O5? Vanadium pentaoxide, or vanadium 5 oxide, as a catalyst to be used. For those people who are uncomfortable with equations using fractions or converting to full numbers, this reaction requires a temperature of about 450 degrees Celsius to take place. So at room temperature, it is not possible. It requires a high pressure. And what's the control pressure? At what pressure in the studio? Hey. So we expect a pressure of about 250 atmospheres for the reaction to take place. If you are uncomfortable with the fractions, convert this into a whole number. Therefore, I multiply the whole equation by 2. Because I said we shall add an oxygen atom. And an oxygen atom is gotten when you get an oxygen molecule which has 2 atoms, you divide by 2. If you don't want a fraction, you're going to add an oxygen molecule. But when you add an oxygen molecule, you have to deal with more than one molecule of sulfur dioxide. So when I multiply by 2, I'm going to get 2 moles of sulfur dioxide, a gas. Will now combine with 1 molecule of oxygen, a gas. Reversible with all those tough conditions, we shall get 2 moles of sulfur trioxide, which is in the form of a gas. So what do we need? We need 2 things here. A catalytic chamber and a thermal chamber, where heating is supposed to be done. We are noting that the reaction is reversible. Such reactions sometimes become very difficult to handle. In the nearby future, we shall see how do you make sure that you favor one reaction only, which is not part of the discussion as for now. So we need a catalyst under special conditions as stated. What are we getting? Sulfur dioxide is a gas. Keeping it is a very big problem. However, it can be obtained in the form of a liquid. What does it mean? You must be able to condense. Without condensation, you cannot obtain liquid sulfur dioxide, because keeping it is a big problem. Sulfur dioxide, even if it's a gas, it can get lost because you will go back and prepare another one with a lot of ease. But if you want this one and you want to use it tomorrow, you have to keep it, because these conditions are not easy to provide. So what would happen if you want to eat a meal of matoke tomorrow, a meat of matoke, noodles tomorrow, your favorites? You just get a packet for today, isn't it? Then tomorrow you get another packet because they're already available. But if you want to eat a meal of kalo today and tomorrow, and you know you have problems with mingling, what do? You mingle once and keep the other one in the fridge, because you don't preserve it tomorrow, you might fail to mingle. But noodles, so sulfur dioxide are like noodles. Anytime you want, you can easily get it. But this one, you can see the conditions are not what? Not easy. That's why when you want to go to the market, if the market is far, you buy items for 1 week. But if the market is the doorstep, hey, I am going to cook, there is no onion, you just jump the market, pick 1 onion, come back. In the afternoon, you go back. Like that, like that. But if it is far, so keeping this one is not easy. So we shall need condensation, and then we shall need what we call what? A freezing what? Mixture. To convert this gas into a liquid. Which means that the setup is not going to be very complicated. Now, don't ask me where sulfur dioxide is coming from. Where is sulfur dioxide coming from? Sulfuric acid and sodium sulfite. I'm not going to go back into that. We now just begin the journey from there. So, what are we going to do? I'm going to have so what is this one here? I'm going to put here what? A catalyst. I'm thinking of a simple diagram that can make me advance my issues. So where does this one go? This one is going to go into a freezing mixture. Maybe this is what I have. And the whole of this is going to be lowered into ice. Not very complicated things. So what is this? This is going to be, so what do we do? So what do you think is this one? So what do you think is this one coming in? And what do you think is this one coming in? Oxygen. And high pressure. And so on. And you come up with what you want. So what is this? It's a freezing what? It's a freezing mixture. What's the purpose of the freezing mixture? The purpose of the freezing mixture is to condense or convert sulfur dioxide into liquid sulfur dioxide. So this now is liquid sulfur trioxide. This is sulfur dioxide gas. It must be dry and clean. So what is it supposed to be? Also dry and clean oxygen, free from dust. So if I'm writing notes, what am I saying? I'm going to pass a mixture of pure and dry, clean oxygen and sulfur dioxide over heated vanadium 5 oxide at a temperature of 450 degrees Celsius and high pressure of 250 atmospheres to form sulfur trioxide. Being a gas, it can be converted into a liquid for storage using a freezing mixture. And that is it. So does it mean we can do this one in the lab? No, because of problems of what? Pressure. However, in a practical, when you heat some sulfur, they give out the gas. But only when the temperature of the test tube is very what? Very high. And the gas fumes in air and continues like that. But after some time, it goes back to sulfur dioxide. So, purely that. So what is the nature of sulfur dioxide? Sulfur dioxide, trioxide, is also an acidic gas that fumes in air. And of course, you expect it also to turn litmus paper to red, but this time it cannot bleach it. We can't test this one using potassium dichromate. I say only sulfur dioxide. So sulfur trioxide, we just appreciate it by looking at its effect of turning blue litmus to red and forming white fumes in air. So when you enter the lab for quantitative analysis, you hit a solid substance and you see something like smoke outside the test tube. And when you put litmus, it turns what? Red. That smoke is due to formation of sulfur trioxide or hydrogen chloride gas, because we accept that hydrogen chloride gas fumes in air. So here we don't have a specific test for sulfur trioxide. It has the same property as hydrogen chloride. Are we there? Then you quickly go into the chemical properties. And the chemical properties are going to be similar to those ones we have been looking at, apart from one of them. You expect sulfur trioxide to react with water. You expect sulfur trioxide to react with sodium hydroxide. It is possible. Why? A base, acidic. Water, yes. Senior 2, oxide of non-metal, which when dissolved in water forms an acid. It is possible. So what will be the name of the acid? Things are going to change. So which means, if we are to look at a reaction with water, it means sulfur trioxide dissolves to form, this time we shall form the most stable acid, which is sulfuric what? Acid. But the reaction is very dangerous. And therefore, our equation, sulfur trioxide, a gas, water, a liquid. This time what do you see? Have you seen there are 2 hydrogens? Sulfuric acid, the formula is SO4, aqueous. The other one gave us sulfur as well as given us sulfuric acid. And therefore, we can also predict the uses of sulfur trioxide already. One of it, preparation of sulfuric acid. Okay, thank you. That is it. The gas being acidic and the sodium hydroxide being alkaline, what do you expect? You can't get a chicken and put it near a fox. It will be eaten. These two are opposite. So what do we form this time? We shall go back in the other business. The other business. If this is too much, what are you expecting? Automatically you are expecting sodium what? Sulfate. What else will be formed? Water. And therefore, what have you seen? I think quickly see that. And it works out. Supposing you have given too much food with little sauce, you are saying SO3, I don't have enough sauce, my friend, but food in plenty. So what is the food in plenty? The sodium hydroxide, aqueous. Too much. What do you expect? You are expecting the sodium hydrogen sulfate, aqueous. Similar to the other one. And I think it also works out automatically. So this reaction and this reaction are similar to the previous reaction of sulfur dioxide. The difference is we have a 4, we have a 4, we had a 3, and we had a 3. Unfortunately, with magnesium, it's not possible because this one, even if you try, you can't separate the two. And these things happen. They can give you a lot of rumors, useless stuff, useful stuff, but say, in the corner, ndagawa. Even if they talk and they say, Nema Mogamba, she doesn't listen. For you, you know, because stable. Whoever tries to Kutomera is the one who falls off and goes away. This was going to happen. So with the magnesium is not possible. However, there are other reactions that sulfur trioxide can also show as given in the notes. But we shall capture these ones, our syllabus tells us. Are there uses of sulfur trioxide? Yes, they are the same uses. 1, sulfuric acid. Number 2 is a fumigant. What are we removing? It does not what? Bleach, and not used as a preservative. So we remain with how many? 2. Having said that, I want to say conclusively that I want you to know how to prepare sulfur dioxide, explain, to draw a diagram. You must know chemical properties of sulfur trioxide, at least 4 important ones I've given. You must know how to convert sulfur dioxide to sulfur trioxide using appropriate conditions of a catalyst, which you must know, temperature you must know, pressure you must know. You must know at least 2 important chemical properties of sulfur trioxide, and you must know at least 2 important uses of sulfur trioxide. Having said that, we are very ready to go into the chemistry of sulfuric acid. Preparation of sulfuric acid. Then we move towards the chemistry of sulfates and close the chapter. And either think of mole concept or something else. So if you can't handle that, then there is a problem somewhere, somehow. The information, the number, you have it. You can send in your questions at a later stage and we'll look at them. So this serves as our end point for today's lesson. But go and read about preparation of sulfuric acid. Thank you so much.